So this is the weekly homework about the graphs and the motion as we completed this topic in the last session. In question 1, a solid plastic sphere fall towards the earth. Figure 1.1 is a speed time graph for the fall and up to a point where the sphere hits the earth's surface. So it's a speed time graph, and it's a speed time graph. Describe in detail the motion. So when the speed time graph is there, we normally use the term acceleration. So from P to Q, because it's a straight line, so what happened to acceleration from P to Q? The acceleration is constant, or there is a constant change in the speed. What happened from Q to R? As you can see, the slope is decreasing from Q to R. So as the slope is decreasing, it shows that the acceleration will decrease. So when you mention explaining this motion from Q to R, you will mention the acceleration is decreasing. And moving from R, S and T, because it's a straight line, so when it is a straight line, it means it is having a constant speed, and when it is having a constant speed, it means here no speed is increasing but the acceleration is decreasing. Abdullah, this first part, acceleration is constant, speed is increasing. The second part, acceleration is decreasing but the speed is increasing. And the third part, acceleration is 0 where the speed is constant, we can mention. Because when the speed is not changing, it means the acceleration is 0. So when you mention in exam, you will mention from Q to R, it is having a constant acceleration because it's a speed time graph. So you should use the term acceleration when you are explaining the idea of motion. And if it's a distance time graph, it's better you use the term speed and as well as acceleration. So acceleration constant, as it's a straight line from P to Q. Acceleration is decreasing from Q to R, and from R, S and T the acceleration is 0. In question 2, a bus travels from one bus stop to the next. In question 1, the speed time, Simon, can you use your mic? Yes, Simon.
Yes, sir.
Look, for a speed time, if it is a straight line, you have a line, a graphical line like this, what you say about the motion, what you say about acceleration, if it's a straight line for a speed time graph. So we say when it's for a speed time graph, it's a straight line, we mention that is a constant acceleration. Speed is increasing but acceleration is constant. What is the meaning of this? That, like example, if an object speed was 10 meter per second when time is equals to 0, then it is 20 meter per second when time is equals to 1, then it is 30 meter per second when time is equals to 2. So what is the acceleration here? The change in velocity. So when you calculate the acceleration or change in velocity, it will be final minus initial divided by time. So 20 minus 10 divided by 1, so acceleration will be 10 meter per second square. Same way, when you calculate the acceleration for the second part, it is also 10 meter per second square. So from P to Q, because it is a straight line, so whenever it's a straight line, what it shows the acceleration is constant. So you will mention in your answer, the first part, it's a constant acceleration. Is it clear, the first part?
Yes, sir.
Then for a second part, the curve, the
From Q
slope
to
is
R?
from Q to R. So if we have a speed time graph and it's a curve and the slope of a curve is decreasing, the angle or the gradient is decreasing. So what we say for this graph, we say that acceleration is decreasing.
Okay.
But what is the meaning of acceleration decreasing or acceleration decrease? Here speed is increasing but acceleration is decreasing. How? Like example, if originally the speed was 10 meter per second when time is equals to 1, then it become 20 meter per second when time is equals to 2, then it become 24 meter per second when time is equals to 3. So what is the acceleration for the first part? The change in velocity divided by time. So acceleration of the first part is 10 meter per second square, because the change in the velocity 20 minus 10 divided by time interval is 1. So that's 10 meter per second square. For the second part, when we calculate acceleration, the final speed is 24 and the initial speed is 20. So when we
Yes, sir.
subtract them, so it will be 4 meter per second square. So you can see the speed is increasing, but the acceleration is decreasing. So we'll have this graph. So you will mention
Okay.
from position Q to position R. So from position Q to position R, you will mention the acceleration is decreasing. And from R, S, and T, it's a straight line. So if it is a straight line, horizontal line for a speed time graph, so what it shows the speed is constant. What is the meaning of constant speed? Like the graphical representation.
It means that it's like stable, like it's not decreasing and it's neither increasing.
Yeah, it's not increasing or decreasing, or speed is same or uniform, or you can also
So,
yeah.
sir, I have a question.
Yes,
For example, when like in the first part you wrote constant acceleration. So,
yes.
sir, what about the speed? Speed will also be the same
No,
because you haven't mentioned.
speed is increasing. You can see here, first it was 10, then speed become 20, then speed become 30. So speed is increasing, but because it is increasing with the same rate, or it is increasing with a constant rate, that's why I use the term constant acceleration. Acceleration refers to change in speed or velocity.
Okay.
And for the third part, we mention when it's a horizontal line, we say acceleration is zero or constant speed. It means that the speed is not changing. So if I explain the motion with numbers, if I say the speed was 10 meter per second when time is equals to 0, when time is equals to 1, speed is again 10 meter per second. When time is 2, speed is again 10 meter per second. So what is the change here? There is no change because it remains same. So acceleration is 0. Here also acceleration is 0. So the third part acceleration is 0. The first part acceleration was constant and the second part acceleration was decreasing. Is it
Okay,
clear?
sir. Yes, sir. Thank you.
The next question, question 2. A bus travels from one bus stop to the next. The journey has three distinct parts, like three separate parts are there for the journey. It is having a uniform acceleration from rest for 8 seconds, and then it move with a constant speed or uniform speed. So the first part, what should be the shape of the graph for the first part? If it's a uniform or a constant acceleration, as we just discussed now, that uniform or constant acceleration, it will be a straight line. So we have to draw a straight line, but till what point? For 8 seconds. So we'll check the axis here. Each box represent 1. So 5, this will be 6, 7, and 8. So this will be 8. So 8 second it move with a constant. For 8 second it move with a constant acceleration, and they mention it starts from rest. So if something starts from rest, its initial or starting speed should be 0. So it start with 0 and move with a constant acceleration. For the second part, they mention it move with a uniform speed or a constant speed. So how we represent a constant speed in a speed time graph? So it should be a horizontal line. So when we draw a horizontal line, that shows that the speed is constant. So we'll represent a horizontal for 12 seconds. So 8 plus 12, it means till 20 seconds, it move with a constant speed or 0 acceleration. Is it clear? The first part of this question. So first it is a constant acceleration, and the second part it is constant speed. Then the third part, calculate the acceleration of a bus for 4 seconds after it leaves the bus stop. So how we can calculate the acceleration of a bus for 4 seconds? Because it's a straight line, so we can use the formula. The acceleration is the final velocity minus initial velocity divided by time. So when time is equals to 4 seconds, this is when time is equals to 4 seconds. What about the speed of the bus? So when time is 4, the speed of the bus is 6. So the final speed is 6 meter per second. And what about the starting speed? Initial speed is 0. So the final speed is 6, initial speed is 0, and the time interval, because for 4 seconds, so it will be divided by 4. So 6 minus 0 is 6 divided by 4, that's equal to 1.5, and the unit of acceleration is meter per second square. So the final answer for the acceleration will be meter per second square, like 1.5 meter per second square. And then use the graph, estimate the distance. Why they use the term estimate? Because it's not a perfect. When you complete the figure and they ask, yes, Abdullah,
Sir, the last question, why it's having 2 marks?
1 mark is for writing a formula, Abdullah, and 1 mark is for writing the answer. As you can see, the distribution, I give you the answers at the bottom. So 1 mark is for writing this, and another mark is for, so you can write the formula in words, you can write the formula in symbols as well. So both ways it is correct. Then the last part, estimate the distance. So I'll just explain the idea that what you will do, you will draw a straight line because we need a distance from 20 to 25. So what shape it is making? It is making a triangle. So you'll use the formula half base into height. In question 3, a car starts from rest, complete one lap, means like complete one lap of in 10 seconds, and that's the graphical representation is there. Figure 1.2 is a graphical representation of the car. Basically it's a toy car. As you can see, the speed is given in centimeter per second rather than meter per second. So a car complete one lap, like when it returned back to the starting point, we call that it completed one lap. So if it starts from point A, it move on the track and then return back to the same point, it means it completes one lap. So it is completing one lap in 10 seconds. The first part, describe the motion of a car between 3 seconds and 10 seconds. So from 3 seconds to 10 seconds, it's a constant speed. So if the speed is constant, we can say that it is having no acceleration or zero acceleration. So from 3 second to 10 second, it is a horizontal line. When it's a horizontal line, you can mention for a speed time graph, it is a constant speed or zero acceleration. Then calculate the circumference of the track. The circumference means the distance. Basically, what is the meaning of circumference here? Like if you have a track, so this is a track, and a car starts from point A and it move on the track and return back to point A. So the distance traveled by the car is actually equal to circumference. So the distance traveled by the car is equals to circumference. So we need the total distance. So how we can work out the total distance? There are two ways. Either you can use a trapezium or you can divide into triangle and rectangle. So if I use a trapezium, the two sides for a trapezium, two parallel sides, this is one. This is the first parallel side. This is the second parallel side. And the difference between them is known as h. So the first parallel side, this one is starting from 3. When I check the x-axis, starting from 3 and ending at 10. So the length of this side is 7. And what about the length of the second parallel side? It is 10. And the difference between them is 25. So we use the distance travel is actually area under the graph, and area of the trapezium, that is sum of the parallel sides divided by 2 multiplied by height. So the parallel side, one of the side is 7, the second parallel side is 10, so 7 plus 10, 17, divided by 2 and multiplied by height or difference between the parallel sides, so that is equals to 25. So when we carry out 7 plus 10 divided by 2 into 25, it will come out as 212.5. And what will be the unit? The unit will be centimeter. Why centimeter? Because speed is given in centimeters. So if the speed is in centimeter, the final answer should be in centimeter. The last part, we need the change in the velocity or acceleration. So they're asking calculate increase in speed per second. Basically increase in speed or change in speed per second. This is a Greek alphabet called delta, which is used normally for difference. Like when we are calculating a difference in the quantity, we can represent by delta. So the increase in speed or change in speed divided by time, basically they are asking for acceleration from 0 to 3 seconds. And it is a straight line from 0 to 3 seconds. So for a straight line, we don't have to draw the tangent. We will use the formula, which is acceleration, in which the acceleration is the change in the velocity divided by time. So the final velocity, this is the final velocity, that's 25. Initial velocity is 0 and the time interval is 3 seconds. So the change in the velocity 25 minus 0 divided by 3. So 25 minus 0 divided by 3, change in velocity you will get as 8.33 meter per centimeter per second square, because the speed is given in centimeter per second, so the acceleration will be in centimeter per second square. If speed was in meter per second, then acceleration will be meter per second square. Is it clear? This question 3. Then moving on to the next question. Question 4. Figure 3.1 shows skier descending a hillside. Figure 3.2 shows the speed time graph. How can you tell the acceleration is constant during the 8 seconds shown on the graph? So acceleration is actually the slope or the gradient. So we can mention it's a straight line with a constant gradient. constant gradient, slope, or angle. These are the terms you can use. That's why if angle is changing, it means the gradient change. If angle does not change, it means the gradient does not change. Then calculate the acceleration of a sphere. How we can calculate the acceleration? Again, it's a straight line. So when it's a straight line, we can use a formula that acceleration is the final velocity minus initial divided by time. So this is the final velocity 6, initial velocity 0, and the time interval that is equals to 8 seconds. So change in the velocity 6 minus 0 divided by 8, so it will be 6 by 8, and then which will come out as 0.75 meter per second square. In question 5, figure 1.1 shows a speed time graph for a car traveling along a straight road. So it's a speed time graph. The graph shows the speed, how the speed of a car changes as a car passes through a small town. So this is the whole speed time graph is there. Describe what happened from A to B, from B to C, and C to D. From A to B, because the speed is decreasing, and they are asking what happened to speed. So what we don't have to mention, you can mention about acceleration, but they are only asking for speed. So at point A, it was having a higher speed, but at point B, the speed is decreasing. So what happened from A to B? The speed decrease. What happened from B to C? Because it's a speed at B is same as speed as C. It's a horizontal line, so we can say speed is constant. And the last ones from C to D, the speed is increasing. Because they ask for speed, that's why I mention only speed. The next part, calculate the distance between the start of the town and end of the town. So how we can calculate the distance between the start and the end of the town? So basically we have to calculate area under the graph. So how we calculate area under the graph? So if we shade the region in exam, you should, when you're solving this type of question, you should shade the region. So from B to C, we are finding the distance travel. So each box on x-axis is representing 1. So basically it is 18 here, and this one is 42. So it will be 42 minus 18, that's equal to 24. So this side, the length of this side is 24. What about the height, the vertical distance? So on x-axis, on y-axis, each box, two boxes representing 1. So this will be 11, 12, and I guess this is 13. So this side is 13. So it's a rectangle. So what is the area of the rectangle? Is it length into width? So length is 24 and width is 13. So you will multiply 24 by 13. You will get 312. As the speed is given in meter per second, so we'll get this as 312 meters. So 312 meter will be the right answer. Then calculate acceleration of a car between C and D. So we have to calculate what is the acceleration of a car from C to D. And again, it's a straight line. So if it's a straight line, we can use a formula that acceleration is a final velocity minus initial divided by time. So first we'll find the speed at D. The point D, the speed of the car. Each box, two boxes representing 1, so this is 31. Because after 30, there are two boxes, so 31. So, and that's the final speed because it is moving from C to D. So final speed is 31. What about the initial speed? Speed at C? Yeah, that's 13, correct, because that was the same height we used to calculate the distance. So that is 13. And what about the time interval from C to D? So when it is at C, the time was 42, and when it is at D, the time is, and this all working you have to show on your graph as well. So this is 42, and here 51, 52, 51, 2, 3, and 4. So this is 54. So time interval is 12 seconds. The final speed is 31, initial speed is 13, and the time interval is 12. So 31 minus 13 divided by 12, you will get the acceleration, which is coming out as 1.5 meter per. V is not minus 4, V is 13 here, 31. V is the final speed because we need acceleration here. This is not minus 4, this is V minus U sine, the formula for acceleration. The formula for acceleration is the final velocity or final speed minus the initial speed divided by the time. So the final speed is 31, initial speed is 13, and the time interval from final to initial to final, that's 12. So we get this acceleration as 1.5 meter per second square. Is it clear to everyone? It's part. V minus u is a formula. V minus u over t is a formula for acceleration. State how the graph shows the deceleration and acceleration have the same numerical value. Means, like, for example, if acceleration here is coming out as 1.5 meter per second square, the deceleration will be 1.5 meter per second square as well. That's their saying. So how we can show that acceleration and deceleration have the same value? So when we check, because when we check the angle, if the angles are same, if they have the same angles, the value for acceleration and deceleration will be same. So from A to B, it is decelerating. And from C to D, it is accelerating. So how we can identify whether acceleration or deceleration have the same value? That's a question. So if the slope or the angles are same, like if I say when we draw the x-axis here, if the angle, slope or gradients are same, it means the acceleration and deceleration have the same value. Like example, if I measure this angle using a protractor, if I measure this angle and say this angle is coming out 60, and I measure the other angle for acceleration, that angle is also coming out 60. So what will happen if I calculate acceleration or deceleration? I will get the same numerical answer. Slope does not depend on the length, Abdullah. Slope depends on the angle. Their lengths are different. That's right. You're right. Their lengths are different, but they might have the same slope. They're not asking for calculation. They are only saying how you can tell whether the acceleration and deceleration have the same value. So example, I will give you an example. Say we have two graphs. One is a longer one, another one is a shorter, but both have the same angles. Slope means angle here. So example, if this angle is appear to be 60. So example, if this angle is 60 and this angle is also 60. So when the angles of a graphical line are same, we say that they have the same slope. So same slope does not mean the lengths are same, this means the angles are same. So if two lines have the same angle, we call they have the same slopes as well. So in the question they were saying how you can say that acceleration and deceleration have the same numerical value. So how we can say they have the same numerical value? Because they have the same angle, or if they have the same angle, then the acceleration and deceleration will have the same numerical values. Is it clear? In question 6, a girl ride her bicycle along a straight level road. Figure 2.1 shows a graph for her distance. So this is a distance time graph. So distance time graph, we use the term speed. So what is happening to speed from A to B as the slope is increasing? From A to B, what happened to speed? So from A to B, the speed is increasing. From B to C, it's a straight line. So from B to C, because it's a straight line, so whenever it's a straight line, what does it mean? It means it is having a constant speed. And from C to D, because the angle is decreasing, so when the angle is decreasing, we say that the speed will decrease. So in the question, they ask, describe the motion from A to B. So speed is increasing, speed is constant, and speed is decreasing. Then calculate her average speed from A to D. So what is the formula for average speed from A to D? Average speed is the total distance divided by total time. So what is the total distance traveled? So when we check the y-axis, we have the total distance, and the total time to complete the journey, that is 60. So the average speed will come out as 400 divided by 60. The total distance divided by total time. So 400 divided by 60, that will give you the average speed, which is about 6.67 meter per second. Then her maximum speed. How to work out the maximum speed? The region where the slope or the angle is maximum, that means it will have a maximum speed. So which region is having the highest slope? So region from B to C is having the greatest slope. So it means it will have the maximum speed from B to C. So basically we'll work out the speed from B to C and we'll get the maximum speed. So how to work out the speed from B to C? So we have to find the distance from between B and C and the time interval. So when we find the distance at B, each box is representing 10. So this will be 10, 20, 30, and this will be 70. And the distance at C, so 310, 20, 30, 40, and I guess it will be 350 as it is in between. So this will be 350. So what is the distance travel from? So when it was at B, the distance was 70 meters. When it is at C, the distance travel is 350 meters. So what is the distance travel between B and C? So 350 minus 70, which is equals to 280 meter. That's a distance travel. Then what about the time? So at B, the time interval is each box on x-axis representing 1. So it's 11, 12, 13, 14, and 15. And C, it is 45. 41, 2, 3, 4, and 5. 45. So the time interval is 30 seconds because when it is at B, the time was 15 seconds. When it is at C, the time is 45 seconds. So the time interval is equals to 30 seconds. Now to get the speed, average speed, the distance, sorry, maximum speed, the distance travel in this region divided by time. So 28 divided by 3 or 280 divided by 30. So you will get as 9.3 meter per second. Is it clear this question? Question 6. So this was exercise. So time to time I will discuss some because it's lengthy exercise. So time to time I will discuss the questions from this exercise.